So just to put things in context, so a programming language gives certain primitive or native data types. So any programming language, it gives some primitive or native data types. And so it is possible for us, no matter what problem it is, we can actually be able to solve those problems using these primitive or native data types. In fact, maybe in a semester or two, you will study what are called as Turing machines, which is a mathematical model for computation. And if you see in Turing machines, perhaps there is no notion of even the basic primitive or native data types. But still, theoretically, we can prove that everything that is computable, we can accomplish using these so-called Turing machines.
Việt Nam sabe. Yeah.
So yeah, but then while it is all right from a theoretical standpoint of view or mathematical standpoint of view, when we actually build software, when we build complex software, large software, which consists of tens of thousands of lines of code, some cases more than 1 lakh lines of code with hundreds of people working together, large teams. It's essential that we need to give structure. We need to make the program readable. And not only that, any problems we would like to, any problems or any bugs in the code, we would like to catch on early. We would like to catch those bugs early at the compile time itself. So, like when you think of catching bugs, so you can catch the bugs at compile time. That is at the time you are compiling the code, or at the test time. That is, test time is the time when you are testing your code. And then there is what is called as a development time. We can skip that. And then after that, you actually deploy it in the real deployment, or let me say, from test you go to real time. Real time is not, there is a notion of real time. That's not the real time I am talking about, or what we call as production systems. Production system. So what happens is, as we keep going to the left, let's say the cost of fixing a bug, cost of bug fixing, it just grows exponentially. I'll use a different color. So at compile time versus test time versus production time, the cost goes up exponentially, especially production time bugs which are uncovered after the software is deployed on a production system. They are very expensive, very, very expensive, because, like, for example, imagine the case, like Toyota or Mercedes-Benz. So they have their softwares released on the cars, and after the cars are all, million cars sold, so they figure out there is a bug, And you cannot simply fix that bug. You have to recall all those cars to a garage, and there no, they have to do a software update. Imagine the cost of it. So production time costs or bugs that are uncovered in production systems, in real systems, in deployed systems, they are very, very expensive. So we want to catch the bugs early on, preferably at the compile time itself. And the most important thing, that tool for catching compile time bugs is by having a very good type system for the language. Is if you have a very good type system, the compiler checks your program for type safety, and any errors which are there in the program because of oversight or some other logic issues, the type system will cover. Usually logic problems, the type system cannot cover directly, but there could be coding problems and things like that, because logic, no one knows, only the programmer knows what the logic is. So here in this context, we talked about, so we want to, the way things work is programming languages, they provide these primitive data types, and then they provide ways to expand these primitive data types so that the new data types can be created. We should be able to expand these data types so that new data types can be created. It's just not enough to have new data types or new domains. The primitive domains are set of integers, set of real numbers, characters, etc. So we want to define novel domains. Like, for example, today's class we will define the domain of complex numbers. We'll define the domain of complex numbers. And so in the last class, and not only the domain, on new domain you want to define, you want to define operators on that domain. On that domain, we have to define operators. We have to define natural canonical operators on the domain, addition, subtraction, or new operators that are there in the domain that we have to define. And the programming language should provide support for defining these new domains and operators on these domains. So I want to really highlight, now we are moving from programming to designing software. Programs are small things which you write in isolation, few lines of code, hundreds or 1,000 lines of code. But when we are building software, these things become essential. So in this context, we have seen that, for example, if you want to create the domain of days, initially we tried out with the hash define. Maybe if you see that code, let's see. Let's open that. This is the code. This days.c with 4 to line 4 to 10, you do hash defines. This is mere convenience, but we are not introducing any new data types by using these macros. So we went to enumerated data type. So we created a new domain of days. But the issue here is we are not able to define operators on this new domain. We are not able to define, like, for example, we cannot say sun plus plus, okay? So we cannot define operators on this new domain. So that's the challenge. But then in C++, it is, we can not only define new domain, but we can also define new operators on that domain. So for example, one important operator that we have defined is this days operator. Okay, so here we have the way to define a new operator plus plus on the days domain, the syntax is as follows. Inline is just to make for program efficiency. We don't need inline, but this is the signature of for defining the plus plus operator. So this the key thing here is operator followed by plus plus. This tells us that we are defining this operator plus plus. We are defining the function for operator plus plus. It's a unary operator, so it takes only one operand. It takes a reference object. It takes an object reference as parameter. It takes an object reference as parameter. That is the days object reference as a parameter. And then it increments and the day and returns the days object reference back. That is how this operator plus plus is defined. An interesting thing here is let's move ahead and then I'll cover that topic. Are you fine with the function on line 46, the unary operator definition? So here again, an important thing is, remember we talked about type safety. C++ wants everything to be explicit, is the type safety. So here what we are doing is we are explicitly doing a typecast of the days to an integer and then performing addition in the integer space. And after that, we are typecasting that back to the days domain. So this explicit typecast is a very important part of the whole type safety system which the programming language provides. So otherwise, in C, you may just say plus plus D, and the compiler may implicitly transfer that D into an integer, and all sorts of those things are possible, but then they are not safe ways to write programs. By writing programs like this, where we do an explicit typecast, we ensure that any bugs in our program are caught early on in the software lifecycle development. That is at the compile time. That's the best time to catch it. We should avoid implicit typecasting in C++. As a principle, as a programming principle, we should avoid it. And then, so the next operator that we would like to overload is the left shift operator. The left shift operator is overloaded in so many ways in the C++ programming language. And many of its overloaded versions code we don't see explicitly. Like for example, so when we have something like cout less than 1 and another statement cout less than 1.0, in this case when it is cout less than 1, something like a function which can print integers will be invoked. And when we do cout less than 1.0, a function which can print the floating point numbers will be invoked. Or if we have something like the same operator is the same, and then if you say string, then a function which can print strings onto the screen will be invoked. So the operator less than is heavily overloaded, in the sense there are so many functions, and which function gets invoked depends upon the operands of this left shift operator. This is a binary operator. So left shift, it's a binary operator. So it has two operands, binary operator. It has two operands. So depending upon the data type, let's say the type here is T1 and the type here is T2, depending upon the data type, actually what happens is, a better way to put it is in the context of, so let's say T1, T2, this left shift operator also helps in bit shifting. Like for example, if this operand is 10 and if this operand is 2, then that means the expression is 10 no, left shift 2, then that means 10 will be left shifted by 2 bits. So that means the result of this expression will be what? If you left shift 10 to the left by 2 bits, 40. Yeah, awesome. So this, if it is, no, if both are of type integer, then what happens is the left shift operation will be invoked. But on the contrary, if this is C out, if this is C out, and this is no, like for example 2, then this data type C out is of type host string object reference, host string. It's a reference, and this is an integer. Then what happens is a function which takes a ostream object reference as input as the left operand and integer as the right operand, that will be invoked. So what this whole thing, where the function that gets invoked based on the input operand types is called as operator overloading. Operator overloading. And when you do here, when you are doing 10 left shifted by 2 bits, you get 40 as the value, written value of this operator. But when you do C out left, C out with left shift operand on 2, what is the written value? Yeah, awesome. C out is the written value. And what is the side effect? There is a side effect to this function call. Side effect is 2 gets printed onto the screen. So there are two things that happen. One is the written value, and the other is 2 getting printed on the screen. And this written value is very, very important, because if this written value is not present, if there is no written value, then a statement such as what we have on line number 71 doesn't work. If there is no written value, what happens is, let me erase this and see, we will see what. Let's say we are considering the case C out. So let's draw, and this left shift operator is left associative. So because of that, what happens is we have C out string. This is the picture that we have. 1. So if C out is not written as the value of this operation, left shift operation on these two objects, what will happen? We cannot complete the evaluation of this expression tree. Yeah, one won't be printed, or we cannot complete the evaluation. You get an error because the result of the type safety system says, you know what, I don't see C out the return type of this operand is void, and void on one left shift operator, and on integer I don't see an overloaded function. I don't see a function which can take one of the operands as void operand, whose type is void, and the other type is int, and you get a type safety error. So because of that, it is very essential that we return C out. But on the contrary, if C out is written, after evaluation, then the C out is applied again on an integer, and the corresponding overloaded operator is operator function will be invoked, and the processing continues. If you return an integer, yeah, then what happens? Then it's not going to help you. You will compute 2 less than 1, it becomes 4 or whatever, but it's not useful for you. So in this particular case, maybe you may think returning an integer might be all right, but what if here you have another, if you have a floating point number? Okay, if you 2.2, what do you mean by integer left shifted by a floating point value? Doesn't make sense. Okay, you're all with me so far in the discussion? Are you all doing good? There is one important point I would like you to appreciate here. That is, now let's come here. Okay, so now we want to, this is the overloaded operator for less than. This C line number 16. And it takes two operands. The left operand is a stream, O stream object reference, and the right operand is a days object reference. And so now there is this, and then so here once you go inside, you see depending upon what day it is, you just print here. Okay. Let's see, and then at the end of the printing, we return whatever the object, O stream object that is given to us, we return it back. The reference, we will return it back. Are you with me on this function definition? Are you with me on this function definition? So here, when we are passing parameters in C++, one important thing you need to remember is, like for example, when we are printing days here, so why are we taking, we are not going to modify the days object, we want to just print it. Then why are we taking an object reference? Why can't the the parameter be passed this way, days D, instead of why are we passing an object reference? You see the option, the second parameter, there are two possibilities. We can either pass a call by value or a call by name. Call by value or call by, not call by name, call by reference. These are the two options. Let me put it, an alternate signature for this function is this. Why are we opting for the second rather than the first? No, not really, Srija, because we are returning object reference for O stream, right? So we are good only. Even that also will work. It's not an issue. What once told, that's not an issue. So Srija, do you realize we are returning the object reference for O stream, that object, not days. So that's not an issue. Oh, you meant for plus plus? No, you can even give the other. Let's see. Let's do one thing. Let's comment it out and see if this works. Shall we try this one and see it works? Both works. This should also work. If I'm right, this should also work. Let's see. We remove all this code. See out. We'll just have. Yeah. Shall we compile? Do you think this code will compile? This should compile. I don't see any problem. See, there is no problem. Either we use this signature or this signature, both will work. Then why are we using the second signature? Sorry. But the preferred one is one we have on line 17. Not because we want to change it later. The reason is passing a parameter by call by name, call by reference is more efficient than passing a parameter by call by. So we have call by reference. Let me write it down. Call by reference, more efficient than call by name. Why is it the case? Can you tell me? Call by value. In the case of call by reference, we just give a pointer to that object. Whereas in the call by value, the whole object will be copied and passed as a parameter. So there is a copy hop, the whole object copy happens here. Copy of the object needs to be created. Because of that, this is not efficient call by value. So you, and of course, other thing is when we do that, any changes to this copy will not be reflected back in the original place. But then on line number 17, we are not planning to modify the day. We just want to display it. Then why should we use, then that's not a problem. If you are planning to modify the day, of course, it's a problem. But we are not planning to modify it. Are you all with me here? What's going on? We are not planning to modify days in this print function that we are going to define. So it's not an issue. But the problem still is we don't want, if you just use call by reference, call by value as in line number 16, then a copy happens, then an object copy happens. And because of that, it is less memory efficient. Are you all with me? Why we want to use line number 17? For efficiency reason. For efficiency reason. But whereas here, we want a reference not for just for efficiency reason. Actually, here also, yeah, we can not for efficiency reason, but we want to modify that object itself. Okay, are you with me here? This is not an efficiency reason on line number 47. We want to modify the days in the increment operator. Does it make sense? Can I see some nods? And one more thing. So when we are writing programs, we don't want to accidentally change. There are two things we want to do. We would like to document our code. We would like to document our program as much as we can in the way we write the program itself. So like, for example, here, we can document the fact that we don't want to modify the days object that is being passed by putting a const keyword before it. So the compiler, it helps in two ways. Let's say when you are reading someone else's code, and when you look at the code, immediately when you see that const keyword, you know that the days, the parameter that is being passed, it's not modified because there's a const keyword. It improves the readability of your program. That's number one. Number two, where it helps is it helps the compiler later on. No, so this is a small piece of code. Later on, someone is working with your yeah. So, like for example, someone who doesn't quite who is reading the code and trying to hack that code to introduce new functionality, and he wants to put ++ here, and then let's see what happens when we try to compile this program. Now you can see, I think this hiding. Can you see? Operand type is constant days, and no, you are trying to increment. Okay. So that is the problem. Are you all with me here? That's how the compiler can help us. That's how you catch bugs at compile time itself. So when you are writing your code, you need to write your code in a very robust fashion. Wherever you can, you should use language features to document the code for yourself, number one. Number two, you pass information to the compiler so that the compiler can enforce what is there in your mind. Are you all with me here? Yes, no? Shall we move on? Okay, awesome. Now, did we write complex numbers code in the last class? Complex.c? Yeah. Oh, not this one. Did we write complex numbers code for structures, using structures? What did I call that one? We didn't define operators. This is the one we did. Yeah. Cool. I got it. Yeah. So what did we do? So now we want to define a new domain of complex numbers. And the way we are doing it is we are defining this struct operation. We are defining this new data type called as complex, and we are using structure, and it has a the structure has a real and imaginary part. And we defined 3 complex numbers, and we initialized the 2 complex numbers a and b like this. A dot real is equal to blah, a dot imaginary is equal to this, and then we define an addition operation on these 2 complex numbers, which adds 2 complex numbers and returns a complex number. Are you with me on this program? So remember, this is all, the parameters are all passed as using the call by value mechanism. What is the, so this is all good. So what is not so satisfying about this code? What's not so satisfying thing about this code? That we would like C is equal to A plus B. This is the one we would like to have. So that will make us happy, because we defined a new domain and we are introducing this we are defining an operator on the new domain. So before I go further, if I would just want to make one important comment. I made this one in the last class, but still would like to make it. So here, when you see this, we are working on this new domain, and we have this left shift operator and then this plus plus. So when we define operators in the new domain, the precedence of the new operators in this new domain, of the operators in the new domain, it is the same as the precedence that is originally defined by the programming language. Like, for example, let's say for your complex numbers domain, you have defined, let's go here. So in the complex numbers domain, you defined, let's say, an addition and multiplication operation. Then remember, when on the domain of integers and on domain of real numbers, multiplication operation takes a higher precedence than addition. So that same precedence is extended even to the complex domain. You don't have a way to change the precedence relationship between addition and multiplication in this new domain. This is what I read and understood. I might be wrong, so you may want to verify. Are you with me? At least what I said, at least you know what you should be verifying. That addition In a new complex numbers domain also, multiplication takes higher precedence than addition. That is a natural precedence given by the programming language. And whether this precedence can be overridden, we don't know. I don't know. You may want to check. All right. So now, so far, so good. So now we want to just not create a new operator addition and multiplication on these complex numbers. We would like to approach this problem in a slightly more complete fashion so that a parenthesis will override. No, that's okay. Good. Thank you, Abhinav. So now we want to come up with a solution which is more complete than the solution provided by the way we have written code here using the structures, etc. That is, now we will use classes. Okay, we will use classes. So initially C++ is called as C with classes, but then C++ prevailed, and which is good only. It's just not classes that is given by C++. It gives us a whole bunch of things. Okay, so complex.cc. Okay. So the way we program in C++, the fundamental entities, remember in C programming language, your program is a collection of functions. Those functions, some functions could be together in one file and some other set of functions could be together in some other file, so on and so forth. That is, but at the end of the day, you can look at your whole program, a C program, it is a collection of functions. And these functions could be spread, in f1.c, f2.c, f10.c. These functions could be spread across, and we know how to do multi-file programming and how we can write nice make files so that we can compile our program easily, and all those things we have looked at in one of the previous classes. But now in C++, the way C++ we supports what is called as an object-oriented program. Object-oriented design and programming. Object-oriented. So here you look at your program in object-oriented design, you look at your program as your software as a collection of objects. And these objects, they interact with each other through well-defined interfaces. They interact with each other through well-defined methods or interfaces. You cannot, like, for example, if there is one object, I cannot just go and change the state of that object arbitrarily. In order to kind of change or mutate or change the state of an object, the object exposes some methods, and we have to use those methods to mutate the state of an object. Okay. So now let's try to define our complex thing. So here, let's start. Hash include IO stream using namespace std. So now we are defining a new class called as complex. And then, so a class consists of some data items. Like, for example, here there is a real number. Sorry, let's use float. There's a float real and float imaginary. Okay, these are the two data items. And then we don't want, right now we are not creating anything. We are just defining a blueprint for the objects that we would like to instantiate later. This is like we are kind of defining our blueprint. Like, for example, when we want to construct a building, we have a plan, right? The structure plan, floor layout, and all that plan, that's the blueprint. Later on, we can instantiate different houses using the same blueprint. Okay, you can, that's what happens in big gated communities, right? There will be one plan, or high-rise apartments is one plan, and that plan gets instantiated multiple times. So we don't want people to come and modify the state of these parts which are internal to us. Okay, so we specify that by classifying them as what is called as a private members. Okay, so we say in our class there are two sets of things. One is private members which are private, and other is set of members which are public. And then, so here we use what are called as get set functions. Okay, so if you want to read the real part of a complex number, so we have this get method called as get real. Yeah, all of you get real. And then you return real. Maybe we can just use small r to make our life easy. We can use templates in classes also, but well, let's solve this problem. Okay, so this is return real. And if someone wants to read the imaginary part, get imaginary. Would you like to get imaginary, or you would like to get real? Bad joke. Okay. So, and then we need what are called as, so you can see that the get real function and get imaginary function methods, these are methods in C++. They are not changing. These are called as get methods, and they don't change the state of the object. But there is nothing that prevents them to change the state. But visually, when you look at the code, we see that they will not mutate the state of the object. But now we will write set methods, set real, float real. So here r is equal to real. Okay, so this is how, and then set imaginary. Nice. So that's all. So the way we are going to, so methods are not always public, it's up to us. But these methods, they provide interface to the external world. There can be private methods also. Okay, so void do some stuff. Okay, so this void do some stuff, this is not, since this is a private method, this will not be exposed to the external world. People cannot access this method. And it is possible to have public data methods also. Something like int count, whatever that means. Okay, so like in which case you can access count because it's a public method. So now that we have this, we can have a function main int. Are you all with me so far? So let's say we define a complex number C. And now you cannot go and do C dot R is equal to, let's do this home. So now let's say, so now we have defined, we created an object C, and we cannot say C dot R if it's equal to 1. And if you go compile, the compiler will, if you compile this code, the compiler will, you can see C dot R equal to this. So there is one more issue here. I think I have to put a semicolon. Do you see the error? Because we are trying to access a private variable. So we get an error. We cannot access C dot R. Okay, so what do we do? Then if you want to set it to 1, what should we do? If you want to set the R to 1, we should call set real function. Should call set real 1 and C dot set imaginary 2. Now it works. And if you want to print this C out, then so C dot get real A, and then we want to press print C dot get imaginary. Are you with me here so far? Those of you who are looking at C++ for the first time, I hope you are understanding what's going on. But then if you see, we don't want to print this way. This is a boring way of printing, right? We should be able to say cout less than C, and automatically the printing should happen naturally. Yes or no? 29 is the preferred way, right? Because line number 27, it is looking very awkward. So what do we do? So what feature of C programming language we use to solve this problem? Not operator overload. Yeah, operator overloading. Awesome. So the way we did the operator. So now let's go back here. Where is our days.c? Okay. So this is what we do. So we use operator overloading constant. Instead here we take complex C, and of course we return out. And what do we do? We copy paste this into cut. Does this make sense? That's all, no? Oh, out less than. Thank you. Okay. So that's all. Now we can, I hope. So there is, when I wrote code for this one, there is something very interesting thing that happened. Do you see the problem here? There is an error. Can someone help me debug this? I know this error because I struggled quite a bit at home while writing this code for the first time. You know, all the C++ code, before I am typing it in here, I'm writing it, practicing it at home because I didn't do enough programming. in C++, any bugs. With the others, all C programs I was typing in straight, but this one playing safe to save time, of course. You're all there. Last time you all helped me out to fix problems. Do you see the problem? So it's not going to help Abhinav. So the issue is, it says passing const complex as this argument qualifiers, and then it says something about this. The same thing about get imaginary. The problem here is the compiler is saying you are asking me to verify that the object C that is being passed is not modified. And then on line number 22, you are calling get real. But I don't know whether get real mutates the state of the object C or not. Similarly, get imaginary may also mutate the change of state of the object. And I am not able to guarantee the request that you are making here on line number 20. That is to keep the object C constant, not change it. Are you with me here? Do you understand? Because you call C dot get real, and get real may mutate the state of the object C. No, so just listen to me, that message is a bit cryptic. Here, when you say const complex C, that is the object that is being passed using call by reference mechanism, we are not supposed to mutate its state. Yes or no? Line number 20, we are not supposed to mutate the state of the object C. Do you agree with me here? That's what const means. But then on line number 22, when you call get real may mutate the state of the object, and the compiler is saying you are calling this function get real, it may mutate the state of the object C. So I cannot guarantee the const request that you made on line 20. So in order to tell, in order to confirm, in order to tell the compiler that get real and get imaginary are not changing the state of the object, we have to put a keyword here called as const here. Not here, this one. Here. So we have to put a keyword const, the keyword const. Once you keep const, then you are telling on line number 9 and line number 10, you are telling that you are not mutating these two functions, these get functions, they are not changing the accessor functions, they are not changing the state of the object. Are you with me now? And then now the compiler will feel safe. Hey, you call get real, but I know that from the declaration on line 9 that that there is no that the function get real is not changing the state, object state. So if you compile now, it works. Does this make sense? Are you with me here? Yes, no? Very cool stuff, right? So I felt good when I figured this out. No, get real doesn't have any parameter. No. So now, yeah, see, now when you want to print this one, render mice, all good, makes sense. We can print complex numbers very naturally. Do you see the power? For all you know, like let's say when you're working with images, when you're working with matrices, you just overload it and then automatically it gets printed very nicely. So now what else we want to do? So now we want to define a natural operator addition on it. So how do we do addition here? Okay, addition is a binary operator. Control. So we want to return a complex number and yeah, addition, it takes complex C1 const complex C2. Complex is a class, yeah. So now we have complex R. So R will hold the result, return R, return. So remember, we are not passing a reference, we are not returning a reference, we are returning a value. Okay, we are returning a value. So R dot set real is equal to C1 dot get real plus C2 dot get real. R dot set imaginary is C1 dot get imaginary plus C2 dot get imaginary. That's all. That is good question from Abhinav. We will see. What do you think the output will be? Yeah, 2 plus 4G. See, we define this addition operator naturally on it. I just pass it C2 times. Are you all with me on this code? What we are doing? Yes, no, maybe. Happy, unhappy. What's all good? So we define a natural addition operator over the domain of complex numbers. Okay, this is a fantastic, we made fantastic progress here. So can someone answer Abhinav's question that why are we doing this? Okay, why do you want to use set real, set blah and all that, whereas you can happily do t dot real is equal to a dot real plus b dot real. Okay. Yeah, we want to make the program robust. Exactly. We are not writing programs. We are building software now. When you are building software, no, that's what I meant, Abhinav. So when it is in public, no, then they are accessible for everyone. People can accidentally access C dot R, C dot I, and all sorts of things can happen. Does this make sense? All good here, no? So far, we define an addition operator. We showed how print thing works. Now, the one important thing that we would like to do now is provide what is called as a constructor to this. Okay, so we have sometimes when we are working, like there is a complex. Let's do one thing. So we would like to have a constructor. So that is when an object is created, then some baseline work we need to do before releasing that, like for example, when a baby is born, you clean up the baby and spruce up, perhaps, I don't know, wrong example maybe, before the baby is presented to the world. Okay. So similarly here, when you declare a complex number, the default, by default, you may all the time want to initialize the real and imaginary parts to 0. Okay, real and imaginary parts to 0. Or sometimes you can have overloaded constructors. You can have something like float. Yeah, they should be same as in on line 22 and line 23. Float A, float, you can have float real, float imaginary. So here we will say R is equal to real and I is equal to imaginary. So now, so these are called as constructors. So what happens is, now when you go to the program here, when we just say complex R, the default constructor will be invoked and the R will be initialized to the complex number 0 plus 0 I. Maybe, sorry, not here, I should go down. C will be initialized to the complex number C1 is initialized to the float, no? Did I keep int? No, right? We used float throughout. So C1 will be initialized to the complex number 0 plus 0 I. And let's say we would like to have the complex number C2 as 2, 4. Maybe let's say 2.2, 4. So now the complex number C2, it gets initialized when C2, when the complex number C2 or the object C2 is created, then what happens is it gets this constructor gets invoked and the real part is set to 2.2 and the imaginary part is set to 4. Are you all with me here? Yes, no? Now let's compile this code and see C1 plus C2, or maybe have one more complex number also, C3, and then we can remove all this. C3 is minus 2.2, 8. So what is the sum of these three complex numbers? Sum of these three complex numbers, C1, C2, C3. 12j, 0 plus 12j. Let's see if that's what we get here. 0 plus 12j. You see how you can use constructors to initialize complex numbers? Are you all with me? Happy and happy? Good. Makes sense? So this is a very big, we took a big leap today in today's class. We defined this domain of complex numbers. It is set to 0 by default because we have a constructor like this, which takes void arguments and but it so happens, Nan Prakash, that even otherwise also it gets set to 0, it seems. R and I, there's a default constructor, even if you don't have what is there on 8 to 11, it still gets to initialize it to 0. It looks like that. Line 8. No, this R and I we have defined on line 26 and 27. No, they are defined on line 26 and 27. Those are the R's and I's we are accessing. Okay. So, yeah, I think we did constructors, operator overloading, and this is what is called as a polymorphism. Okay. Two different functions with different signatures. Depending upon the signature, the compiler will invoke the corresponding constructor. Like for example, here, this C2, C3, and C1. In the C2 and C3 case, the compiler invokes the right constructor based on the parameter types that are given here. So you got introduced to a whole bunch of new ideas. Very important ideas. They are very, very useful for you while writing the programs. And so I strongly encourage you to code this up and extend this to multiplication operation and see how it works. Yeah, that's true. That's how it identifies. That's how the compiler knows that it's a constructor. That is how the compiler knows that it's a constructor. Otherwise, you may need to, compiler may need to introduce some other word called as something like constructor and do some name, okay, XYZ. You do something like this. So maybe something like that. Otherwise, how will the compiler know it's a constructor or not? So now, this is all I have to. Yeah, I don't understand your question, Anika. Think about it, and we'll. Time is 11:10. Perhaps we should stop here. So Amoga, we saw no, when there is a private variable, when we try to access it, what did you get? Do you recall when we tried to say c dot r is equal to, in main when we do c dot r is equal to 1, we got a compilation error. So in object-oriented programming, we want to encapsulate data. We want to encapsulate the data and the methods which act on that data. So we are doing data encapsulation. We are encapsulating or hiding this data R and I. We cannot access them directly. When we try to access them directly, it doesn't make sense. No, you can have public after private, private after public. It doesn't make any difference. All good. Any private stuff you cannot access directly. Only the public stuff you will be able to access. And you usually have what are called as get set functions in the public space, using which you can mutate or read the state of the object. You want to read the state of the object or you want to mutate the state of the object, you keep them like that. Okay. Like for example, if you want to keep a count of the number of times getReal function is accessed, okay, count underscore getReal. So the number of times the getReal function is accessed. So when you call getReal, then what happens is you can say count underscore getReal plus plus. We can have this statement. So when so it tells us the number of times and get count real, it's an internal thing for you. You want to keep track of different statistics, and it's not available for the external user. So you keep that variable as a private variable. Make sense? Are you with me here? Okay. When I compile this code, do you think this program will compile? This program wouldn't compile because we said this function doesn't mutate the state, but then we are mutating the state. Yeah. So what do we do? So let's say, yeah, so we cannot mutate the state. But if you have it here, it should work. Instead, let's say you want to count the number of times setReal function is called. It works. So why it works? Because setReal function, we don't have this keyword const here. So that means we are permitted to change the state of the object through the setReal function. It's by mistake. Line 20. Are you all happy? So that's all for today. I hope you understood how did it work. I removed the setReal. No, it works, no? It's an empty statement. You can have as many as you want. It's an empty statement. Okay, so that's all I have to